We're going to look at absolute and conditional convergence next. On your flow chart, that's up here in this top right-hand corner, and it's not really connected to anything else. And the way that you'll know that you need to be doing this process for absolute and conditional convergence is that the problem will actually state that. It'll say, is this series absolutely convergent, conditionally convergent, or divergent? So you'll be directed to use this process pretty clearly. All right, so let's take a look at the details. So the first step is you want to take the absolute value of your series, and you're going to look at that and see if that converges or not. Okay, if it does, then it converges absolutely. Your original series converges absolutely. If this absolute value version of the series diverges, but your original one without the absolute value still converges, then you have conditional convergence. Okay, and then if you fail both of those, so in other words, if that absolute value version diverges and the original guy without the absolute value diverges, then all we've got left is divergence. All right, so let's look at this with a series that we're already pretty familiar with. Let's look at the alternating harmonic series. So the process is we always test for absolute convergence first, and then we work our way down. So my first step here, I'm going to say, is this absolutely convergent? I'm looking at the series of the absolute value of -1 to the n minus 1 over n, which is the series of 1 over n. So we recognize that, that's the harmonic series, and we know that it diverges. So this is not absolutely convergent. Okay. So that means the next step is to test to see if it is conditionally convergent. So we've got divergence here, so we're going to look at the original series without those absolute values. So I'll make a note here, conditionally convergent question mark. So I have -1 to the n minus 1 over n. We know from earlier in this section that this is the alternating harmonic series, and we know that that converges. That means that yes, this is conditionally convergent. All right,